This module is going to be covering rigid bodies mostly. Now, we briefly touched on them in an early module, but starting now we're going to go more in depth. Firstly, rigid bodies have three different types of physics: dynamic, kinematic, and static. We're going to start with dynamic first. Dynamic is the default option. It's used to mimic physics in the real world as closely as possible, and it offers the most options, the consequence being that it's most taxing on the physics engine processor. Now, the next option may look very familiar, and it acts the same way as it would in the colliders. You just input a physics material, and it mimics that physics material. Generally, it's good practice to only do it in the collider component, but since this is a small educational exercise, it shouldn't be a problem unless both slots are filled. Simulated is basically gravity. Check on if you want the object to be affected by gravity. Check off if you don't want gravity to affect it at all. Turning off gravity is usually good for like floating platforms or decoration objects in the background in levels. Automass lets the system estimate the mass of an object automatically. Automass lets Unity estimate what the mass of an object would be. The smaller the object, the lighter it is. The bigger the object, the heavier it is. This is rarely used, but it's still in handy if you need it. Alternatively, most devs, myself included, use the mass option to edit how heavy an object is. Gives you a lot more freedom and versatility to edit your objects. Linear drag and angular drag are both options that increase the resistance of an object. Linear drag affects the position part. Angular drag only affects the rotation part. Though be careful with these options. If you're not careful, especially with angular drag, it can make things look really awkward and janky. Gravity scale basically affects how the object is affected by gravity. For example, if you put in the negatives, it's like how normal gravity works, where gravity's constantly pushing down at us. Positive gravity scale equals normal gravity, i.e. where it's pushing down on us. Negative gravity scale equals high gravity, meaning we'll float up. There is a second way of doing this, but we'll cover that in a later module. Now getting into some really juicy stuff. Collision detection is basically how our rigid body relates to the colliders it detects. Discrete is the default option, turning off gravity on one dynamic rigid body while colliders and rigid bodies dynamic pass through each other. Continuous is the exact opposite. Game objects with colliders and rigid bodies cannot pass through each other. Moving on, discrete collision sleeping mode defines how the rigid bodies and colliders sleeps in the sense of saving processing power. Two objects with both kinematic rigid bodies never sleep means it's active all the time, always. So it's always taking up processing power. If the game or project is running below 60 frames per second, this should be avoided whenever possible. Within this project, it's not going to chug. We should be good. Start awake means it wakes up at the beginning, meaning the first frame. It saves some processing power, but not much, but it's really handy when there's very little objects. Start asleep means it's initially asleep, but can be woken up by any collisions. It saves the most processing power, but is not used all that much, and used in very rarefied situations. Interpolate usually deals with smoothing the object movements when things get a little janky. Best used for flight sim since it deals with both position and rotation. The none option is exactly what it implies. It does nothing. Interpolate smooths the object's position based on previous frames. Extrapolate moves the object's position based on what it predicts the future frames would be. Interpolate is the one most commonly used, because extrapolate could be very, very unpredictable. Constraints freezes the position and rotations based on the axes. For example, if we If we don't want to move in the x-axis, we could totally do that. If we don't want to rotate at all, we could totally do that. Usually in 3D, we have access to all three axes, but Rigidbody2D only gives us access to X position, Y position, and Z rotation, because there's one less dimension to deal with. Now we've covered discrete, now we're going to move on to kinematic. Kinematic is designed not to be affected by gravity or other forces, but can be moved under very specific user control circumstances. We'll come back to that in a later module. It's faster and lighter on the processor, but its options are much more limited. It cannot collide with other kinematic rigid body objects, but they can still collide with dynamic rigid bodies. By toggling on use full kinematic contacts, the object will collide with all types of rigid bodies, else the object will only collide with dynamic rigid bodies. And the rest of the options is stuff that we've covered before. Like I said, dynamic has the most options. Static is really simple. Static has the least amount of options, but is the easiest on the processor. It's basically for objects that are designed not to move at all. Zip. Like the kinematic rigid bodies, it can only collide with dynamic rigid bodies. Now that we've thoroughly covered Rigidbody2D, we can now play with the options and see what we could do with them. Feel free to experiment if you want to. Otherwise, I'll see you in the next video.